this activity, we're going to get a feel for how to think about a qubit in a quantum superposition using a simple analogy, a spinning coin. So far we have learned that unlike a classical bit, which can only be a 0 or a 1, a quantum bit or a qubit can represent a 0, a 1, or some combination of both 0 and 1 at the same time, which is something a classical bit can't do. Now, when a qubit represents a combination of 0 and 1 simultaneously, we say that the qubit is in quantum superposition. For example, the arrow on the block sphere here represents an equal amount of 0 and 1 at the same time, called an equal superposition. But there are many other superpositions that a qubit can occupy too. In particular, every direction in which the arrow can point, other than straight up or straight down, represents a different quantum superposition. Now, one thing that all superpositions have in common is that when we look at or measure a qubit in a quantum superposition, we won't actually see the superposition. Instead, we'll randomly find the qubit in either the 0 state or the 1 state, and it's impossible for us to predict which one. For example, if the qubit is in an equal superposition, then there'll be a 50% chance of seeing the qubit in the 0 state, and a 50% chance of seeing it in the 1 state when we measure it. To help us better understand the behaviour of single qubits in superposition, here we have a normal coin. This one is a 20 piece, but any other nicely rounded coin should work as well. Now, if we take this coin and spin it quickly on a flat surface, like this table, then you can kind of imagine it as both heads and tails at the same time. This is similar to a qubit in a quantum superposition, which represents both 0 and 1 at the same time. So we can think of the spinning coin like a qubit in quantum superposition. Next, while the coin is still spinning quickly, if you slap your hand on the coin flat, the coin will randomly land on heads or tails. This is similar to what happens when we measure a qubit in a superposition. We'll randomly find the qubit to be in either the 0 state or the 1 state. We can think of slapping the coin flat as an analogy for measuring a single qubit in superposition. Try repeating this a few times and you'll see that the outcome, i.e. heads or tails, will change randomly, just like the outcome of measuring a qubit. This time, we see that the outcome was heads, but if we repeated the experiment by first preparing the qubit in a superposition and then measuring it, this time the outcome was tails. So while the coin spins, it can be thought of like a qubit in superposition, which occupies both the 0 state and the 1 state simultaneously. And when we slap the coin flat, this is just like measuring the qubit and randomly finding it in either the 0 state or the 1 state.